Okay, thank you. Fine. In the last few class, we have been studying the CSMA, the carrier sensing multiple access protocols, right? Then in this one, we have seen the one persistent, non-persistent, and p persistent strategies, right? Then we have seen the CSMA CA, right? Means carrier sense multiple access with collision detection. So the basic idea behind the CSMA CD is that a station needs to be able to receive while transmitting to detect a collision. Right? And when there is no collision, the station will receive only one signal that we call the its own signal. Correct. And whenever we say there is a collision, right? Whenever we say there is a collision, correct? That means there are two different signals will be there in the channel, right? The very first one is, for example, station A, right? Station A, right? So its own signal, the first signal is its own signal. Fine, good. So its own the data of the station A sending to some XYZ station. And as we are saying, there is a collision in the channel or the carrier, right? So there must be existing of the one more signal, right? And that signal is the signal of the second station. The signal transmitted TXTD is transmitted by second station. Correct. So in a wired network, the received signal has almost the same energy as a sent signal, right? Suppose station 1 and station B is there, and both are connected with a dedicated link. Okay, wired link. I'm not saying the wireless link, right? So here these both the signals, right? The energy in the link will be having the same, right, throughout the cable. Okay, and sometimes somewhere the signal strength will be going to decrease. So in order to avoid that, so we will be putting the repeaters in order to strengthen the signal, or in order to make the signal as it was the original, right? So in general, what we can say, the amplifying the signals. So in order to keep the signal intact as it is, so we will be putting the repeaters throughout the link, right? So this means in a collision, the detected energy almost doubles, right? Because the normal signals, right? Suppose this is the signal, correct? Original signal sent by the A. You can think of station A is sending, correct? And similarly, the station B will be also sending. So suppose like this is there, correct? So suppose like this is there. So this is the resultant signal of the B. So both whenever we combine, right? And whenever we calculate the energy of the signal, it will be doubled. So something like this, the energy signal will be there. So this is the energy signal. Okay, energy signal. So it's very easy to detect in the wired node, right? The wired network, it's very easy. We can easily now estimate the energy which is available in the link or the carrier or the medium. Correct. So what about in the wireless? How to do that? Right? In wireless, the medium you can say the open medium air. How do you measure the signals energy? Right? So it's a impossible to measure the signals energy in a wireless network, right? The and whatever the nodes, right, at the station, the base station and base station, wirelessly both are communicating with each other, right? And here we cannot, or practically it is not at all possible to detect the collision in this case. We can detect at the station B or at the station A, right? How? Just by using the acknowledgement. Other than this, we cannot. This is also acknowledgement if you are thinking. So according to the acknowledgement or the timeout, all right? Only using only these two, we can get to know that there is a problem in the link, right, on the wireless medium. So it's not a good idea to send it at the rate it was sent in previously. So it says that sender, you need to reduce the sending rate. You need to reduce it. Then it will reduce and it will send, right? So this is how we will do it. But practically we cannot detect the errors, right? So in the wired node or the wired network, we cannot avoid the collision, right? But we can able to detect it, right? But in the wireless, we cannot detect the collision, but we have to avoid the collision, right? So this is the main basic idea or the basic problem behind the CSMA CA. CSMA CA means carrier sense multiple access with collision avoidance. So in the wireless medium, we can avoid the collision through the or the using the three main strategies. One strategies we can say has interframe space IFS. Interframe space IFS. The second one strategies in order to avoid the collisions in the wireless medium is the contention contention window. It's the second one, right? And the third one, acknowledgement. So these are the three strategies we'll be using in order to avoid the collisions in the wireless medium. Okay, so let's see the one more in terms of the pictorial diagram, which we have seen earlier. So in the same way, we can think of this also. So we can think this is the time, right? Suppose the station A senses the medium at this time, right? And it feels that it's a busy medium. So right here, it's a busy. So what it does, it's continuously senses the medium whenever it senses the medium is busy. Continuously it will sense. Okay, CSI. This is continuously sensing the medium, right? And when it's a idle, right? Suppose here it's a idle. Whenever it feels the medium is idle, right? At that time, what it has to do is it has to defer the sensing, right? This period of time. So this period of time, what I'm calling as the interframe space, IFS. So it has its own formula to calculate what exactly the length or what exactly this time period is for the IFS. Okay. Then again it will sense, right? Here it will sense. And if it again found idle, then the station doesn't suddenly transmit the data or the frame. What it does is here it will use the binary exponential strategies, or what we can say is it's a contention window. Contention window. I will tell you each and everything. What is this contention window and what is the binary exponential strategies? And the binary exponential back of strategies, right? Then after this contention window, still the medium is idle, right? Still the medium is idle, then only it will start sending the frame. Send the frame. Send it frame. So this is the basic idea of CSMA CA. So again, I will repeat here. The CSMA CA, it is used to avoid the collisions in the wireless medium. So in order to do so, it has a three main strategies. The very first one is the interframe space. The second one is the contention window, and third one is the acknowledgement strategies, right? So at the beginning of the CSMA, right, the one persistent, non-persistent, and pre-persistence, we have seen that whenever the stations finds the medium, okay, busy, then it will continuously senses the medium until it finds the idle. And whenever it finds the idle, in this case, means in this CSMA CA, it will defer its transmission for the period of IFS. That we call the first strategy is interference space. And after this time period, again it will sense the medium, right? And again, if it is finds idle, correct, then it will wait for the this amount of time. So this we call the contention window. And this contention window, we will be calculating using the binary exponential back of strategies. So we call BEBS. And after this time period, again the same station will senses the medium. If it still finds the channel idle, at that time only it will start sending the frame sequentially, right? So this is the basic idea and the strategies in order to avoid the collisions in a channel, right? So the first one which we have seen the strategies is the interframe space, right? That is the IFS interframe space. So the collisions are avoided by deferring the transmission even if the channel is found idle, right? In the previous here I have told you, right? Even it is found idle, it will defer its transmission, right? And when an idle channel is found, the station doesn't send immediately because in the earlier cases, right, in CSMA CD, what the main issue was, the station A here is there, correct, and the station D here was there, correct, and when it senses the channel and it finds the idle, right, and it was sending like this. correct? So this is was at time T1 and station at time T2, right? At time T2, it senses the station, senses the channel, and it finds it's a idle because the station is whatever it has transmitted the signal or the data, it has not reached at the time of TT, right? So D, what it presumes that the channel is free, nobody is using it's a idle, then it will start sending the frame, correct? So as a result, there is a collision here. Right? So whenever the collision happens, right, whatever the data was there, so the complete data will be. So this was the situation, right? So in order to avoid that, so we are, even though the channel is free, channel is idle, we are deferring the transmission so that if the station is a distance, right? For example, 10 meter or 100 meter away from the station A, right? And that might have started the transmissions, right? So in order to avoid that, collisions for that transmissions, right? We need to wait for some more time. So that amount of time we call the IFS. Right? So IFS time, it allows the front of the transmitted signal by the distant station to reach these stations, right? And if after the IFS time, the channel is still idle, right? Still idle, the station can send, right? So after the IFS time, the station again senses the channel, and if it is still idle, right, it can send the frame, but here it will never or it won't send the frame, right? So it will wait for the contention window, right? So in general, what we can say is IFS, right? For each of the stations will be having the different IFS time period, right? So in general, what we can say, IFS provides the priority to the stations, right? So that is the IFS. The second one, the contention window, right? So the contention window, so it's an amount of time divided into slots, right? Suppose this is the amount of time. This is the contention window. And in this contention window, what we do, we will be dividing the slots in this time period, right? This time period. And a station, right, that is already all it's ready to send the frame, right? It chooses a random number of slots here. So that is it's a waiting time. Okay, so the number of slots in the window changes according to the binary exponential backoff strategies. Right. So whenever we say this is the contention window, means the amount of time divided into number of slots. Right. These are the slots. So the next question will come. How many number of slots we have to make? Correct. And this how many slots, that will be depending upon the binary exponential backoff strategies. Okay, so means it's a completely random in nature, right? So it's set to at the very first, okay, whenever it will detect, right? At that time it will set as a one slot, right? And the second step, whenever it detects and if it finds it's a BG, channel is busy, right? In the second time. So this is the first time. And second time sensing. So what it does is it will double the slot which was there in the previous time. So the double means here it's a two slots, right? And in this second, sorry, in the third time, suppose the station finds, right? The station finds it's a busy, right? Again, it will double. So now it's a four slots, right? So like this, it will increase. So 4, 16, right? 32, 64, right? 128. So like this, it will be increasing, right? Till the number of transmission attempts, I know that whatever the constraint is there, that is the 16 or 12. So till that constraint, it will be transmitting the information, right? So this is the contention window. Fine. The third one. So this you guys already know that is the acknowledgement, right? So with all the previous precautions, right? If you take and after taking there also, there still may be a collision, right? Which is resulting in, or destroying or, dropping some of the information from the frame, right? Or the data may be corrupted during the transmission. So we will get the two kinds of acknowledgement, right? Positive acknowledgement and the negative acknowledgement. And also we are having in this the timeout operation as well in order to, help the or in order to make guaranteed the receiver has received the frame or not, right? So in this one, we can have the acknowledgement, positive or negative acknowledgement, right? And we will be having the timeout as well, so that we can easily figure out what is happening in the network, right? So with respect to that, we can, reduce or increase the transmitting rate of the sender as well as the receiving rate of the receiver. So this is the basic idea of the CSMA CA, correct? With a three different strategies. So now we will develop the algorithm. CSMA, carrier sense multiple access with collision avoidance algorithm, right? So of course, the first what we have to do, we need to start the algorithm. So let's start. So we have started the CSMA CA algorithm. Okay. And so at the very first, whenever we start, the main basic function here is the transmission, right? So there, the number of attempts we are making, so that one we need to initialize here. So at the first we are doing, so we need to initialize the number of attempts as a 0. Correct? Now, so after initializing the number of transmission as 0, now we have to what the very first thing what it has to do, the station, it has to detect the channel, correct? So we are having the one condition block here. Correct? So this is the first transmission. So here, whenever we detect the channel, we will be seeing whether the channel is idle or not, right? Idle. channel or not. This is the condition in this. Correct. So for this, we are having the two different answers. One is the no, correct, and the other one is yes, correct. If the channel is not idle, okay, so this option will be activated and it will be selected. So it's going back here. Okay, then so if the channel is not idle, right, it's a busy. Right? So whenever it's a busy, so according to the strategies, right? So how many strategies we have seen so far in the CSMA CA? Only three, right? So the first strategies is the interframe space. So we need to, our station need to wait for IFS amount of time. So that is the interframe space time. Correct. So after waiting for this amount of time, the station, what it does is again it will senses the channel. Correct. And if it is a free, oh, we are having two options again here as well. One is yes, one is no. Idle is, so channel is not idle. So what it has to do? It has to initiate or initialize the number of transmitted. And if it is not idle, okay, it's not idle, then here, right? So now the second strategies will come into picture. That is the contention window, right? So that contention window, that's a random in nature, right? And that random in nature that we can calculate using the parameter called the number of transmissions, right? So that I'll write. So I'll be writing as choose a random number, right? Random number R. Choose a random number R, correct? And this R values is between 0 and 2 raised to K. Whatever the K we have initialized, that K only, and minus 1. Okay, so this one we are calling as the contention window. Window, sorry, window with size is K minus 1. Right? So after choosing the random number using this choosing R between this range, correct? It has to wait for whatever the random number we have or the station had chosen. So that we can write it as wait or slots. Right. So we have seen here these slots, right? How many slots we uh, we will be getting, right? And these slots, I'm saying that range will be 0 to 2 raised to K minus 1. Correct. So this will be chosen by the random number R. Right. So the station will wait for our slots, right? Then after each slot, right? If it idle, then it will continue, right? For transmitting. And if it is not, idle, if it is a busy, right? Then what it does is it will halt and continue when it is idle, right? So it continuously, in general, what I can say is it's supposed to go here. One more, sorry, here, correct? I'll take this block only, correct? So it will again senses here after each slot or the whatever the slot we have chosen. So again it will senses. If it is idle, correct? If it is idle, okay. If it is not idle, if it is busy, what it has to do? It has to again choose a one random number and wait for the R slots. And if it is not a idle, right, then it will send a frame. It will send a frame, right? Then now from now onwards, it's as usual. The earlier the timing diagram, how we have done. So what we have done after sending a frame, we will wait for the timeout, right? We'll wait for timeout period. Wait. Correct. We'll be waiting for timeout. Then after the timeout, what we will be doing is whether acknowledgement has received or not. Acknowledgement received or not, we will be checking. Correct. And if the acknowledgement is received, correct. Yes. Then whatever the frame the station has sent, it has successfully transmitted. So it's a success. Okay. And suppose the acknowledgement has not reached, right? Due to some reason, it might have lost somewhere, or the data frame might have lost it. Okay. So now what we have to do is we have to, sorry, so we have to increase the number of attempts of the station, whichever the station or the sending station is there. So that station number of attempts we need to increase it, right? And we have seen in the previous all the algorithms, whenever we increase k equal to k plus 1, then after that we will again check, right, whether it has reached its limit or not. Right. So we'll check that. Means whether k is greater than k max. Than k max. right? So if it is yes, if it is yes, if K is greater than F, you have to abort the portion process or drop the complete frame, right? Suppose if it's not, and it has not reached its limit, correct? So what it has to do, it has to again sense the channel. So from here we can put. Okay, and again it will, the same process will be repeating. Correct. Now it's a k equal to 1. Then again it will sense. Again, if it is the same thing, k equal to 2. And again. So it will be doing the, it reaches to the maximum value k max. Okay. So this is the CSMA CA algorithm. Any doubts for students? Any doubts?
No, sir.
Okay. Then we'll stop for today.